It has been mentioned, I'm a researcher at the Potsdam Institute for Climate Impact Research, briefly called PIC. It was founded in the 90s by Hans-Joachim Schellenhuber. Some of you may know him. It is one of the big chiefs in climate change research. We are about 300 staff people with also about 100 guest researchers. What we usually do is to work on scientific crucial questions in the regard of global change, climate change, that's anyway in the name, but also other changes like trade changes, climate impacts in the big frame of sustainable development. We do so by being very intra and transdisciplinary. That means we have many people coming from many disciplines, a bit similar, I think, like here, the Cornell University, really with the task of kind of overlapping the disciplines and getting rid of this monocultural perspective. Our main tools, and that's what we are usually doing, is programming, coding, and building up from little to big computer models. We have a big computer cluster also in our house to do the future scenarios, as it has been said, for the Intergovernmental Panel on Climate Change, or the IPBES for biodiversity and ecosystem service assessments, for example. My lab has been mentioned. The lab is on land use management, and we do not only do computer work, we also go sometimes, at least outside. It's kind of a bit of an excursion into the nearby forests. So we are not totally nerdy, so to say. And to come in terms of content, I would like to start with an important, relatively clear, but still sometimes forgotten saying that land is where we live. I mean, without land, we wouldn't be on this planet in the end. And it's not only that we put our feet on the land, it's also that land provides us with many, many services. I mean, just some obvious ones that are very clear. It's like it stores carbon. That's one of my major disciplines, land-based climate change mitigation. It stores carbon in the vegetation, in the soils. It's also kind of, you want to like go out, you have kind of a leisure issue if you go out to nature. It produces food. Yeah? And those different services, they sometimes even intervene and interact with each other, either to a co-benefit or rather to a trade-off. And if you look then at the Sustainable Development Goals, I guess most of them know about the SDGs, so I don't have to go too much into detail, but those are 17 global goals. Global is an important thing, which is relatively new compared to the Millennium Goals, which kind of have to be or want to be achieved until 2030. And if you look at land as a driver for many of those SDGs, it gets obvious that it affects almost every SDG in the end. Just to pick up a single SDG here, and that's SDG 2, zero hunger, food provision in the end. And the study from Benjamin Bodirski that he did in 2020 to project the food demand into the future based on age structure, based on population growth and income. And this is the outcome for a business as usual. We call it an SSP2. That's a bit in the technical terms, but this is kind of how the world would develop if we do it the same way as we did in the past. And what you can see that in the past, the demand for agricultural commodities increased very strongly. And if the models are right, it will do the same if we don't change things into the future. And the good news is in the end that people being undernourished, at least the share, has at least partially been decreased. And if it would not be me talking, but Robert Malthus, I mean, he was an economist in the 1800s, so to say. He would state, if you look at this production part, that population at some point would outstrip food supply. In terms of mathematical terms, it would mean, if you look at this figure, time on the x-axis and y on the quantity on the y-axis, his kind of philosophy behind his saying is that if population increases exponential, and if production of food does not do so, but rather linear, we at some point have an intersection where we don't have enough food provided to fulfill the demand of population, and we run into a Malthusian catastrophe. On the other side, there's another colleague, it's Esther Boserup. She was a Danish agricultural economist, and she would state, being here with us, that the power of ingenuity, that means new development, so to say, would always outmatch that of demand. If I translate that again into a figure, I hope you can see it besides the upstairs links here. Again, quantity and time. And you can see that we again have an exponential growth of population. But in her philosophy, it's rather that always if the food supply what you would see is that the food supply does not intersect with the population in this case, because at the moment it would get into touch, the innovation aspects come into the game, and we have new ways of producing food, therefore always avoiding the Malthusian catastrophe. So the question is in the end, who is right? And if you look at the historical production of food, might it be animal products or crop products? It was always increasing in almost all world regions, maybe not that much sub-Saharan Africa. But I'm out again. The reason for this increase, so more or less supporting Boserup's thesis, is that we had a lot of agricultural expansion. I think many of our terrestrial systems are occupied by either croplands or by pasture areas. On the other side, maybe in the most recent decades, due to the Green Revolution and such aspects, Haber-Bosch producing industrial fertilizers, we have a strong increase in, oh, that's in German, but these are different world regions, Africa, Americas, world region. We can see that the corn yields in this example, based on FAO data, has tremendously been increasing. And this is the reason why one could say that Boserup was right and is on the perfect side. But if we do the next step and think a bit more integrative in terms of agricultural production, you can see that what you would spell out here is the externalities of agricultural production, that all this comes at costs. For example, the expansion of agricultural land led to a loss of natural land. Greenhouse gas emissions occur from this kind of land use changes when agricultural cropland with low carbon content replaces high carbon density, for example, tropical forests. But also the production of food creates a lot of nitrous oxide, methane emissions, the so-called non-CO2 emissions. Nitrogen pollution, lots of our groundwaters, but also eutrophication of ecosystems has been taking place due especially the intensification of agricultural systems. Water withdrawals for irrigation, about 70% of the human used water happens due to agricultural irrigation. All this comes to a loss of biodiversity, climate change impacts, eutrophication of agricultural, but also other ecosystems in freshwater or even more terrestrial systems, as well as a loss of habitat. And all this interplays into the future, and it's something we already can observe now, but might be even more dramatic in the near future. We'll have an interplay again with food production, because the degradation of areas may happen, and therefore lower yields could be expected in the future. So that means we really need an integrated perspective, and in this means it might be that Malthus might be right that at some point of time, the production of food might be lower due to these externalities, and the feedbacks included. So translating this into the challenges for integrated land use modeling, I have a bit of a list of what such kind of models may need, and I don't want to get too much details, but just to give you a brief overview, it needs an integration of both biophysical and human economic data and processes. That means decision of what to do based on the biophysical resources. It needs an integration of different temporal scales, short-term versus long-term. Not so much maybe for food production, but for long-term investments in the timber industry, it's an important aspect, or investments into innovation that needs something like a decade to get into reality. Different spatial scales, local versus global dynamics. That leads me directly to the integration of markets and trades. That means displacement effects. For example, if somewhere forests are getting protected, it might mean that agricultural production then switches from Brazil maybe to the Congo basin, having there its effect. A competition for land and water resources. That means we really have to integrate different land uses in one system that even play with each other. Agriculture, forestry, conservation. Technological change in agricultural forestry has to be included, because if we have seen many of the agricultural production increases happened due to the intensification in agricultural production. Multi-sectoral interfaces. It's not the land use system playing alone its games. It interplays with the building system providing timber for building processes. It interplays with the energy system providing biomass for bioenergy, for example. Land use consequences. We talked about this trade-offs. That means biodiversity has to be in there. Pollution, greenhouse gas emissions, food security impact. And also, as I showed before, the impact of what does it mean if it's kind of mismanaged the degradation process. And then in the end, it's about humans. We need human behavior, policies, values, and institutions at different spatial scales. And then it's a big thing. It all has to be based, if you want to do it at a global scale, based on consistent data along different scales and the topics. So it's a complex issue that we try to tackle with our in-house model. It's called MACPIE, the model of agricultural production and its impact on the environment. I don't want to get into too much details, but to give you a rough and brief overview what such a partial equivalent model usually looks like. It includes socioeconomic decisions, socioeconomic data, mainly at the regional, but also spatially explicit data. It's global, and it also includes biophysical inputs. In this case, is our main model we interplay, it's a DGVM, a biophysical model called LPGML. It derives for us at a spatially explicit 0.5 degree, 50 by 50 kilometer at the equator level, biophysical yields of crops, of pasture land, land and water constraints. So we really have a river routing system in the model, as also soil carbon aspects. And then in the end, it's an interplay between including trade, supply, and demand aspects, deriving then land use patterns, water scarcity patterns, deforestation rates, but also biodiversity, food prices, and such things. This is more or less the framework in a nutshell. We started very simply. It's in the meanwhile open source. We are MACPIE 4 model, that's how it's called. It started relatively simply with being only looking at crop, demand, and some drivers, some policies included, spatially explicit data, and also socioeconomic reaction schemes at the regional scale. But over time, to lots of corporations, yeah. I thought you end with, I'm really bothered by this. No, all good. No, all good. But what you can see is that we try to extend it to be really integrated. That means we included also forestry system, livestock, again, not in detail, but it shows you how complex such a model can get into the end. It's all open source, so if someone would be interested, give me a hint or give a hint to the team. We're really keen on distributing our knowledge in these terms, not only the code, but also the data. Good. Multi-sectoral, I mentioned, we don't play alone with our sector. Just very briefly, we also interact in terms of different interfaces with, for example, energy system models or macroeconomic models to have this kind of external drivers, how we call for the land system, but also to have the multi-sectoral perspective. I would like to go briefly now into some examples. As I said, really briefly, mainly only a few figures. Let me start with one paper we did in 2014, which is on the land use protection for climate change mitigation. And what I can show you here are 3 different scenarios. One is a reference scenario, business as usual. No climate mitigation takes place. And what you can see here are the land use dynamics for in the main 3 aggregated categories: brown cropland, forest green, other land, that's something like abundant agricultural land or shrublands, something not forests, and pasture grasslands. And what you can see in 2100, you have an increase of these land use types at the cost of those on the left-hand side. And you can see without any carbon protection, cropland increases at the cost of forests and grasslands. If we do a red scheme, that means reduced emissions from deforestation and degradation. That's what is discussed, putting a price, carbon price, for example, on land use types that emit carbon. It would lead to a scenario until 2100 where cropland is still increasing, but now not anymore on the cost of forests, but mainly on the cost of pastureland. So the forests are protected. And if we put a carbon price on all kinds of land uses, including pastures that are prone to emit due to the high carbon content below in pastures emissions, we get a very static land system to protect this kind of carbon in the vegetation in the soil. In consequence, and that's important also policy message here, is that these are kind of the CO2 emissions in megatons per year, historical and future ones for the 3 scenarios. And you can see in the baseline emissions occur over time. In the forest protection scenario, you still have fairly a lot of emissions in terms of CO2 because you have the loss of the pasture areas. And only if you get into the static all protection scenario, you go down to 0. And that translated into the policy arena, it means many of the NDCs, the nationally determined contributions for the bottom-up plans of the different countries, don't totally disregard this integrative perspective, only looking in the end of the forest protection. We have the issue in Brazil, for example, where the protection of the forest in some former times led to a loss of land in the Chaco and Cerrado areas, where you also have a lot of carbon and also have a lot of biodiversity. Just having said that. Another mitigation aspect that is of very big importance is bioenergy with carbon capture and sequestration. In the end, the philosophy here is that CO2 from the atmosphere sequestered in trees, then harvested, burned in a power plant, and not being transferred back into the atmosphere, but caught and dig down into the earth mainly. That's the theory behind it. And the big climate models, and this is one scenario of a MACPIE remind, that means our model in an interplay with energy system and macro system model. You can see the reference case, no mitigation, lots of fuels over time. The sum is that is a black line. And if you want to go in RCP 2.6 case, it's more or less a 2-degree target, not even a 1.5 target, a 2-degree target. You can see that we have to go down very strongly, and in the end, lots of negative emissions might be needed. And those models, they very much like, if you don't constrain them, to use the biomass from land to produce via the BECCS technology negative emissions. In terms of climate change, it sounds great. In terms of land use, it might be an issue, because in the end, it must be something like 300 exajoules. And what we did in an assessment using the MACPIE model, we did a reference scenario without bioenergy, one with an exogenous input of 300 exajoules, which is fairly a lot, but more or less responds to what you've seen in the negative emissions needed in this kind of integrated scenario. It comes from dedicated grassy and woody plants like miscanthus as a grass, or eucalyptus or poplar from trees. And then we try to see what are the negative consequences and what measures do exist to avoid those negative consequences. So this is kind of the bioenergy effect. And again, 2100, that's a classical timeline until when this IPCC scenarios usually are getting set up. And you see CO2, gigaton CO2 cumulative emissions, that means cumulative over time since 2010. We have a no bioenergy scenario. These are the cumulative emissions. And if we add this bioenergy shock into the system, you can see that the emission from land use change, mainly deforestation, get really huge. We also looked at other indicators. I only want to show in the matter of times 2 of them. Water withdrawals exceeding environmental flow requirements. That means we can protect and also assess how is the quality, not the quality, the quantity, and that means the amount of freshwater systems harvested, and how does it harm potential resilience of this ecosystem. So if we kind of now in the next do a protection of environmental consequences, we protect the forest, as you've seen before, the REDD scheme. And we can see emissions go down, not fully because we still have this pasture, grassland, other natural land emissions that would happen. And the same happens if we protect the environmental flows in the freshwater system. It works, but also you can see if we protect, for example, the freshwater system, much less water is there for agricultural irrigation, and therefore more expansion has to happen to fulfill the demand for agricultural commodities. And you can see that then the CO2 emissions, again, if you don't protect the forest, get much higher. So you always have the trade-off between these different angles of sustainability. If we go into land sparing, that means either more intensification in agriculture or less demand in terms of livestock commodities, which are very resource demanding, you can see that it's almost the best strategy to control those elements. And if you combine all of them, that means the land sparing together with the protection part, we can, at least in the level of these 2 indicators, greenhouse gas emissions from CO2 and water flows, we can go almost lower than it would be in the baseline case without bioenergy shock. So there are solutions, but we really need a very holistic perspective on the land system to go into the right direction. If we talk about sustainable development, I try to rush a bit through this, even if it's worthwhile talking longer, but time is restricted. If we talk about sustainable development, it's not only about the land system. There are many other dimensions that have to be considered. And you can see here happy people being happy in 2015 in France at the COP, announcing the willingness for 1.5 and all these things. But the main thing that I want to highlight here is that they decided, and it's an important thing, that climate change has to happen in the context of sustainable development efforts to eradicate poverty. And if you look at that, we try to do an integrated assessment, taking many different sectors into account, where we do a climate action pathway with our MACPIE remand system again. That means the energy sector, transport sector, building sector, including the land use sector. And how can it be aligned with the rest of the SDGs? One thing that I briefly want to say here, this is an assessment of what the different models currently before this assessment could do. And you can see they are very strong in terms of Earth systems and the interaction with other SDGs. They're very strong in terms of resource use, but they lack the economic, social, and many other environmental conditions. So what we try to do then is to build up a framework, this is the MACPIE remind interaction, and adding many other models to be able to get a picture of the full SDG cluster. So we started with a classical scenario, changed more or less towards a more sustainable scenario that's called an SSP1, including a national determined contributions for climate change mitigation, which are not enough for reaching a 2-degree target. Those are kind of changes in population, GDP, in trade, more sustainable food demand, but also on the management level, higher nitrogen efficiencies, efficient animal waste management systems, and livestock production systems, getting rid of first-generation bioenergy and such things. We went in addition to another scenario where we included a 1.5-degree target for climate change mitigation by constraining the emissions with a budget. And then in the last step, we went towards an SDP, a sustainable development pathway. That means we even increased the efforts for sustainability in all dimensions, but we also invented different measures to protect and avoid the fight against the negative consequences of one measure spilling over into negative consequences in another sector's measure. So what you can see that we really covered all of those SDGs. It was really huge effort. We have planetary integrity, where, for example, biodiversity indicators coming from our model. The blue line, by the way, is the most sustainable one. I'll go into more details in a second. Prosperity, material needs, people, but also political institutions and peace indicators. So it's really kind of a very integrative perspective what we did there. But I would like to dive deep a bit more into the agricultural and food sector, because that's more mainly my sphere. Just very briefly, not looking in the results, but explaining this kind of waterfall diagrams. So the combination of reference trends, faster development towards a more sustainable world than compared to today, climate action, that's the green bar, and then adding additional sustainable development interventions, as I mentioned before, enhancing the progress and compensating existing trade-offs. Now to the results, what we can see that is a transition towards a sustainable nutrition, the Eat Lancet diet, for example, leads that in the end towards a reduction in 2030 of underweight people, and also being able of kind of diminishing the negative consequences of land-based climate policies, because there's just simply less resource-intensive production needed. If you look at planetary boundaries, agricultural water use, nitrogen fixation, biodiversity and technicness in 2050, we can see again that this very sustainable development pathway, the blue bar, the last step, so to say, is really needed to push our planet, even if climate change mitigation takes place, into the sustainable dimension. Without that, it would be very complicated. So we have to be very, very stringent in terms of doing sustainability measures. And the very important thing is in terms of spillovers between sectors. I mean, that's relatively clear. These are different measures in different sectors, energy and food, maybe to highlight here. And then you can see in terms of underweight, it's mainly the land sector that helps us to go down to the sustainability dimension. Food price index, as I've shown before, the same. But if you look at the final energy price in the energy sector, it's very interesting. The most important measure is going towards more sustainable diets for energy, for decreasing the energy prices in the energy sector, because it means we have to produce less agricultural commodities, also feedstock for animals, and that means that less emissions from agricultural systems, like the non-abatable, the residual emissions from non-CO2, methane, nitrous oxide would occur, that would increase the budget for other sectors, and therefore less efforts would be needed in the energy system, and therefore the energy prices are much lower. That means the biggest trigger for making the energy system affordable is the food system. If we talk about integrative land use modeling, one part that we try to work on very hard in the last years is to broaden the perspective. That means increasing new indicators, going multi-sectoral, and have the interfaces between those. But if we talk about a real representation of land systems, we also have to do a deep dive. That means we have a better understanding. We have a need for a better understanding and a better representation of the processes that lead to the dynamics in the land system. Let's come to one thing that's more and more a buzzword. Before it was ecosystem services. Now it's nature's contribution to people that comes from the best world, so to say. And what I want to highlight here is that there are many, many services, again, as I did in the beginning, that contribute to human well-being. Might it be biomass production, for what kind of a purpose? Might it be timber production? Might it be carbon sequestration, food production? But then there are also regulating services that have a benefit to people via affecting, for example, agricultural production. And if we have a degradation of those systems, that means either pollinators get lost, or we have soil erosion systems and therefore less carrying capacity in agricultural systems. Well, how does it affect in turn via affecting the provisioning services, the outcome for human well-being? Just as an example in terms of thinking, this is a study we did a while ago with one former Times PhD, now postdoc, Majra Stevanovic. And the idea was to include biophysical climate change inputs in terms of agricultural yield, as it is done here from the LPJML model. Here you can see agricultural yields in terms of corn. How does climate affect it? These are the decreases and increases, decreases across the globe. And then we try to translate this into producer surplus in agricultural terms, to translate it into consumer surplus, and in the end, into agricultural welfare. We don't yet fully have the climate impacts under control. I don't want to talk in detail about that, but I just want to replace the climate change aspect in terms of what does it mean if we lose biodiversity and pollinators? What does it mean if we have land degradation in terms of soil organic matter losses or whatever in terms of the production? And how is the translation then in terms of human well-being? We started briefly in doing so with one of my PhD students, Patrick von Jetze, and we tried to assess together with other partners the impact of this kind of high provisioning services to be foreseen in the future, like food production or biomass production for bioenergy, in terms of pollination, but also soil organic matter, soil erosion, which I don't show here. But the pollinators are really of utter importance for at least for some of our agricultural production aspects. And this is the outcome of the MACPIE study, where we together with Justin Johnson from University of Minnesota from the Natural Capital Project and his SEALS model try to scale down our outcomes to a level of 300 by 300 meter, where these kind of processes really take place, because at the resolution that we usually have is 50 by 50 kilometer, it doesn't help us at all to get a hint in terms of what are the ecological processes and their interaction. And what you can see here, that is due to a kind of habitat homogenization and loss of natural areas, we have 3 different categories of pollination sufficiency. We can see the green one, very sufficient, and then it's going down. Very sufficient is meant as an agricultural spot that has a minimum distance of 2 kilometers to the next natural area where pollinators could persist. So we can see that already today in 2015, we have a lack of agricultural areas that have a high pollination sufficiency. If we translate this into the future, with a BAU scenario, but also with a scenario that aims to do biodiversity protection, as well as a scenario that on top to the biodiversity protection wants to do a carbon policy, thereby preserving forests and high carbon density areas, we still can see that it does not really have a big effect on the pollination sufficiency in terms of global percentage of cropland. Again, these 3 classes. Only if we add on top of this the constraint of having 20% of semi-natural habitat within the grid cells, only then we can increase the pollination sufficiency. So it means the major outcome of this integrated perspective, again, is that we really need dedicated methods for improving the landscape heterogeneity to increase this kind of supporting service of pollination. 5 more minutes. and I'll start with my first slide of my vision, so it seems to be perfect in time. What we really need in the future is a holistic perspective on sustainable environmental or land systems. It means we need capacities and capabilities in model assessments to go into the future for assessing the consequences of global change. In this term, it's different trade patterns over the globe. How do they affect different services and supporting services, for example, like biodiversity? That's doable. We also need to do it in a way that it can be translated. What does it mean for human well-being? The study I just shown translates at the very late stage into pollination sufficiency, but we don't know yet what does it mean for human well-being. There are local studies, but it's really difficult to translate it to the global stage. And then we need to identify, if we have such a framework, what are the options out there, how we can really get into the real world, what are the measures, what are the policies to be handled and used for sustainable land use, ecosystem services, and biodiversity future. And in the end, it has to be a consistent system that also tackles potential co-benefits and trade-offs. That means the different dimensions really have to talk to each other. That we really build up a system, and it's something that all these kind of models really lack at the moment, that can tackle the consequences and helps to avoid potential land degradation. Let me end my presentation with a famous German guy, Alexander von Humboldt, who once stated that that's the only German saying here, alles ist Wechselwirkung. Translated into German, it's all about interaction or trade-offs. Many thanks for your attention.
Incredible presentation, Alex. This is what a way of starting the seminar series. I think that there's so much food for thought here, and some great questions will emerge. Phenomenal. So the floor is open.
Could you briefly say who you are and which department?
Hello, everyone. Thank you for
Go ahead. Just have to get it very close.
Thank you for the amazing talk. I'm Rashmi. I'm in the MPS program for global development. How do we? There's all of this is great work, and what I want to see is if we don't follow this path, obviously we are in the path of doom. How do we translate this to the common man who doesn't understand all of this? And I'm talking from the Indian perspective. People are just coming, people are just growing and moving into the small, from poverty levels to middle class levels, and the middle class is sort of bulging, and the middle class, that is the newer middle class, has aspirations. They want to get a car, they want to do everything that so far they have not been able to do and have always aspired. How do we get them on board? Because without them, these goals are really, really tough.
Yeah, that's a very good question. I fully agree. I mean, I have to say, in the end, it's all a bit shocking because all I present here, in the end, is on the table since a long time. Maybe not in such an integrative perspective, but we know that many resource-intensive diets have an harm on land, are more land demanding, nitrogen pollutes the stuff. Yeah, I mean, that's all out there. It's just a question for me, and this goes a bit in the, I can't give a full answer because I'm a bit frustrated about the fact that it's all on the table, but we don't act. I mean, climate change impact is maybe one of the biggest examples here because it's in the media, it's out there. We see the extreme events happening, flooding, whatever, the burnings. So it's just simply that nothing happens. So the question is how we can get there in the game. And I personally think, as you mentioned, kind of developing and emerging countries, I think there are countries, there's a need of the more developed countries to start first and to show that you still have a human well-being perspective if you adapt to a more sustainable world. And in the end, it's not that we will have to suffer if we go into this direction. I mean, this kind of less meat-demanding diets, they are much more healthy. If you do biking, and you gave the example of using a car, if you go biking, it's much more healthy, it's much more environmental friendly, it's much more relaxing, it's much more beautiful in the streets if you have kind of a bar out in the street and not a car slot to park your car. So I think in the end, we need more positive messaging in kind of the high income countries to do really the first step and to show us an example that it's doable, and then it would be translated into the emerging and developing. You need the mic? I think it's important also for the video conference people.
Yes, I mean, we can lead by example, but the common man is already riding a bicycle, right? And he's aspiring to get to on a motorcycle, because that's what his idea of development is like. I'll earn more money so that I'm more comfortable, and I reach from point A to point B without this hassle of everyday bicycling to my workplace, right? For him, that is, yes. How do you, and that number is not small. When we, and it's unfair in so many terms, because the developed world has already sort of seen and enjoyed that privilege, and the developing world is trying to catch up there, because that's the picture and the idea of development for the developing emerging markets or emerging countries. And now we are saying, no, bicycling is good for you. So it's, how do you bridge this gap? It's important that we get that message, but how? When you have these challenges, where it's like, oh, I thought when I have a better economy, I would get this, and now you're saying no, go back.
Yeah, the question for me, I mean, I fully agree. It's also the question how neo-colonialistic it is also in the end to come up with such messages. Yeah? But in the end, I'm really convinced that it's, as you said, like in the high income countries, you could enjoy it for a while at least. So why shouldn't we be enjoying it now? It's always a question of definition. The point is, did we really enjoy it? Is it the better path than being more sustainable in the end, also for the developing or the developed already countries? That is something I think in the messaging that would be really needed, because that's what I doubt for a bit. But in the end, I mean, we can't, as you said, we have to do the transformation, because otherwise the consequence, I use your words, which I fully underline, we would be doomed at the global level, independently of who you talk to and what it will be.
Hello, I'm Christopher Brown, Baker student in real estate, finance and investments. Love, this is awesome. Now, construction, 39% of greenhouse emissions, construction buildings. Now, how can we practitioners in the marketplace at least do our part? I know we have low carbon concrete, different battery storage, things of that nature. But how do you think is the best way for us to really do our part in solving these issues?
I think on the 30th, next week, we will publish a paper in Nature Communication, especially on how timber housing would benefit. In the end, the idea is how the further urbanization buildings needed until 2050 could be built on the basis of substituting this kind of more conventional materials that you mentioned, based on timber houses, so to say. And we compared, and we also did include this additional timber demand into our land use model to see in the end what are the land use consequences of doing so. And the major consequence is that it doesn't necessarily have to compete with the food production areas. There might be a need a bit more intensification, but it's needed anyway. Let's call it sustainable intensification, whatever it means then in the end. But it would, and we can also protect biodiversity hotspots, but it still would mean that we have to harvest other natural land or secondary forestry areas where we build up new plantations. So it means the emission consequences and the food are much better in comparison to the conventional building materials, but it has definitely a footprint on the land, and it also has biodiversity consequences. Again, a very good example for integrative land use perspective and the intersectoral spillovers. In the end, you always have to look what kind of sustainability target you take care of. Good for food, or better say, good for the greenhouse gas emissions, much better than conventional materials. Okay for food, but not so good for biodiversity. So that means you again have to take a deeper look into the biodiversity consequences, what it means. And also climate resilience is an issue there, because if you have this kind of plantations, they're much less resilient for extreme events in the end. The question is how permanent is this carbon being used then later in the buildings over time, that we didn't consider. But this might be one option to do so. And there are also kind of use of potential former plastic particles Yeah, Maria knows well about the study. But yeah, but it will come out on the 30th.
Sorry, I think that we have a question from somebody online. David K. David, would you like to pose your question?
Sure, can you hear me?
Very well.
We can hear you very well.
Okay, thank you. Very interesting talk, and it's really exciting to see the effort at integration across so many fields and disciplines and data sets and scales and everything you started out with. My question is, in terms of making an impact on, the kind of changes, policy changes, where would you suggest the most important investments need to be made in improving the modeling that you're doing now? And as a corollary to that, I assume you've learned a lot about what Cornell does and doesn't do well. Where would you see Cornell research and extension and teaching sort of fitting into that vision of how what you're doing could be improved?
Yeah. I mean, first of all, I don't see any kind of global land use modeling here at Cornell. That's one point. The other point is, in the end, what we as global integrative land use modelers do usually is to work very interdisciplinary. I mean, we are not the experts on all of those things. We usually then interact a lot with the discipline experts to get a right setting into our implementations. That's an important part. But if I think in terms of what is the next most important pathway, I think it's really creating consistent scenarios for the climate change mitigation world. That means IPCC, in consistency with the biodiversity and ecosystem services world. That's the best. There are some efforts going on at the moment, but in the end, all this kind of degradation and negative consequences on these feedback loops via pollination, soil erosion, whatever it might mean, climate impacts, that is not fully solved yet, not at all. And I think that's really maybe nothing for, like, let's say, the next 2 years, but it's something that has to start now to have it in the midterm in 5 to 7 years at hand in a consistent way. Sorry? I think Cornell already contributes fairly a lot in terms of, like, let's talk about measures, for example, biochar options in the mitigation portfolio. I mean, we have to be as comprehensive as possible. And I mean, there are many experts in this direction here around that can help to feed jointly information into these kind of large-scale models. The other thing is also that it's a large-scale model. We try to go down to fine scale with solutions to kind of consider those processes happening there. But in the end, it's also very important to have more local scale models, from agent-based models to more kind of really farm level models, where we have kind of an umbrella setting in terms of consistency making coming from the global models to be fed into those models, that you have a better level of comparison between those. Because that's something I think sometimes lacks, the comparison level between different regions.
Okay, I'm going to allow one last question.
This is Jamarin Isgima from Burundi. I'm a Humphrey Fellow. I'm really worried about how developing countries, my question is a bit general, how developed countries will be able to emerge and develop themselves in different sectors with less harm to the environment. Because we tend to follow maybe the path of the developed countries, and following that path may be harmful, more harmful to the environment. And what can you suggest as one of the ways we can do for us to develop, but without harming the environment?
I think the most important thing is the leapfrogging, so that you jump over environmental harming, or I mean, if the environment is harmed, it's also society being harmed, but kind of sustainability harming, so that kind of technologies that might be developed can be transferred and easily and adapted to the other regions where this development did not take place, enabling those regions jumping over a development state that would be like coal emissions or something much more harming to the environment. That's also the task of the more developed and already kind of having these solutions at hand regions to deliver that then to this kind of less developed countries and regions downscale. I think that's really a very important part of it. And to also show, and that's also the task I very much think of the more developed regions, to give showcases that this kind of sustainable development leads maybe to another and a different way of well-being, but it leads to a well-being and thereby increasing the acceptance rate of this kind of development process at a more global level.
Okay, Alex, thanks a lot for very lively presentation. Well, please, let's